This is Dr. Holt. In this problem here, I want to find the tension in each of the cables below, and I want to find the acceleration of each block. So what I have is I have a pulley. It has no mass, and that is very important. I also have a mass that's hanging here that has 5 kilograms. This has 3 kilograms, and this mass has 5 kilograms. We'll go ahead and just label the tensions to start out with. We'll call this one to be the T1. We'll call this one to be T2. And we'll call this to be T3. Okay. Now I'm going to identify what direction I think the acceleration is going to go. And I'm going to assume it's going to accelerate this way. Now, one thing to note, it really makes no difference. For example, you don't have to look at the system and say, oh, I have to get the acceleration right. You could have the acceleration going back the other direction, and that's fine. It's just when you work all the mathematics, what will happen is you end up getting negative acceleration, and it just means you have it going the wrong direction. So we'll make the assumption here the acceleration is going to go counterclockwise. Okay, the first thing you want to do now is to draw yourself a force diagram or a free body diagram of each one of these blocks. I'm going to start here, work from here to here to here. So if I take the 3 kilogram, I'll draw a dot here representing the 3. I'll have two vectors. I'll have the force of gravity here. So we're going to call that the force of gravity, and that's going to be the Earth onto the 3. Again, there's different ways to set this up. Some people put the 3 in respect to the E. As long as you're consistent, you're going to be fine. That's going to be a vector. So we're going to identify that as its mass, which is going to be 3 times 9.8, and that's 3 kilograms times 9.8 meters per second squared. That's going to give me a value of 29.4 newtons. This here, we'll call it T3. Again, label that as a vector. That's going to be the only two forces you're going to have. And now what I like to do is we've assumed the acceleration is going to go down off to the side. Oops, let me do it again. Off to the side. I will call this as the mass, which is going to be 3 times the acceleration in the y direction. Again, all I've done, I've established a coordinate system, and the coordinate system I'm using, I'll just show you right here, is the coordinate system I'm using is this. This is going to be, I'm letting anything that goes up be positive y. Anything that goes down going to be minus y. Anything that would go this way, which we don't have to worry about here, would be positive x. So that's the coordinate system I'm using. So from this one right now, I can go ahead and write myself an equation. I can say that the summation of all forces in the y direction must equal to the mass of the acceleration in the y direction. So when I do that, I will get minus 29.4 plus T3 is equal to minus 3 times AY. Okay, so that's going to be my first equation. Now I'll jump up to here, and I got some open space here. I'll draw it right here. When I do the 5, let me get a vector, sorry. This will be my T3. Also have one more vector coming down here. Got to consider the force of gravity here. I need to show these a little bit longer. And again, we've labeled that as our T1. This will be the force, gravity. Again, that's going to be the Earth onto the 5, which will equal its mass of 5 kilograms times 9.8, and 5 times 9.8 will give me 49 newtons. And here I should have been more consistent and put the newtons in here. Okay. Alright, so that's what we have here. So if we can go ahead and generate an equation from it, and I'll put it right below this one. Again, we're going to summation of forces of y equals mass times acceleration of y. When I do that, I will get minus 49 minus T3 plus T1 is equal to minus 5 times acceleration of y. I'm going to add my vectors here, here, and here. And then when I did this, when I left one thing off here, again, I like to do this off to the side, as to make that into the mass, which is going to be 5 times AY going down. Again, that's where this whole equation, summation of forces in the y direction is equal mass times acceleration. That's my second equation. Okay, we have this other one to draw. I'll draw my force diagram or free body diagram right down to here. I will have two forces on it. I will have the force of gravity of the Earth onto the 5. Again, we know that that's going to be 49 newtons. This will be T2. And again, we know that we've assumed it's going to accelerate up based upon what we did up here. By this going this way, the acceleration will be up, and that will be 5 times AY. From that, we'll go ahead and generate our third equation. We will be minus 49 plus T2 is equal to 5 AY. Go ahead and draw these as make our vector notation in here. And that's our third equations. Now, it may look like you have more unknowns. You do equations, however, you have three equations and you have three unknowns because T1 and T2 are the same. So let's talk about how many will identify what we have here. We have this one and this one. They're the same. I'll do this one in green. We have T3 here and here. And the other one we have is a y here, here, and here. So we have three equations. We have three unknowns. This problem is solvable. The first thing I'm going to do is I'm going to develop a strategy, but what I want to do on this one, I want to take the third equation. What I'm going to do is solve for T2. Since T2 is the same as T1, I'll put it back into this equation here. And then I will have two equations, two unknowns. So watch me do this. I'll take this one. We can say that T2 is going to equal to 5 AY plus 49. Okay. I'll write that as red, or circle that in red. We will take that one, and now we're going to substitute it right back into right here. When we do that, that gives us minus 49 minus T3 plus T1, which we said T1 and T2 are going to be the same, 5 AY plus 49 is equal to minus 5. AY. Okay, we'll go ahead and simplify that. Move the 5AY over to the other side. That's going to give you minus 10 AY. Now you notice the 49s are canceling out here and here. So on this side that gives me minus T3. So now we know that T3 is equal to 10 acceleration of the Y. Alright, so now we have that one. All we have to do now is substitute that back in right here, and the only unknown we'll have is a Y. We're going to do that now. So we had minus 29.4 plus T3 is equal to our minus 3AY. We subtract 10AY from both sides. We solve for acceleration of Y. That'd be 2.26 meters per second squared. So that is our solution. We found out what the acceleration in the Y direction is. So now the tensions are going to be easy. We can come back to T2, use this equation right here, substitute back in what the AY is going to be, and then we're going to get T2 is equal to 5 times 2.26 plus 49. Tension 2, which is going to equal to T1, is going to be this value here, and that will give me 60.31 newtons. And then to find T3, the easiest way is use this equation right here, and we know that T3 is going to equal to 10 times the acceleration we have here, 2.26, and that will give me 22.6 newtons, and that's going to be the value of T3. Okay, and these are the steps I would recommend. Again, establish the direction you want acceleration to go. At that point I'd be consistent. If you have it going the wrong way, what will happen is at the end when you do this you'll end up getting negative acceleration. It just means you established it going the wrong way, and you would just change it, and that was all you'd have to do. However, work through this methodically, draw good force diagrams or good free body diagrams, sum up all your forces, set it equal to mass times acceleration, and you can solve these problems. Again, I got 3 equations, 3 unknowns. You can do a combination of substitution, elimination, or as you learn how to do matrices, you can set this up into matrices and solve that way. Alright, best of luck.